Good morning, students. Welcome to this tutorial of signals and systems. In the previous session, we studied about evaluation of integral, which involves unit impulse function. It may be the original unit impulse function, or it may be a shifted version. We did the evaluation in continuous time, and then we calculated it in the discrete time also, right? So you need to remember only one equation, that is integration minus infinity to infinity x of t delta of t minus t0 is equal to x of t0. That's it. Okay, it is equal to x of t0. You need to remember this equation, and then you can evaluate the integral easily. Fine. Then we studied about sketching a signal, particular signal, as u of t plus 2 minus u of t minus 2 plus u of t minus 1 minus u of t minus 1. Right? How to sketch it? So first you sketch u of t plus 2, then you sketch u of t minus 2, and then you subtract them. So you get a signal which is a rectangular one. Okay? It starts from minus 2 and ends on 2. Similarly, you can have u of t plus 1, and then you can draw u of t minus 1. You subtract them, you get a rectangular signal which starts at minus 1 and ends at 1. Fine. And then you add these two signals, u of t plus 2 minus u of t minus 2 and u of t plus 1 minus u of t minus 1. You add them and you get your original signal, which is x of t, and it is given by u of t plus 2 minus u of t minus 2 plus u of t plus 1 minus u of t minus 1. Right? Fine. Now x of 2t means we are doing the time scaling. We have drawn this time scaling, okay, and then we found that it is compressed. The original signal is compressed, right? So you get minus 1 to 1, the same signal but compressed 2 times, right? So the revised signal has the same shape, same amplitude, but it begins at 1, ends at 1. Sorry, begins at minus 1, ends at 1. Fine. Then we were supposed to find out x of 1 minus t. So what we did, we flipped, or we did the time reversal, right? Because the signal is symmetric with respect to y-axis, so we got the same signal. So x of minus t was the same as x of t. And then, so this was the example of flipped version, right? This is, if this is x of t, the right hand one will look the x of minus t, and we call it the flipped or the time reversal or the fold. Fine. So then you get the x of minus t here, and you add plus 1 to the time everywhere, and you will get a signal, resultant signal, which will look like this. Fine. And then the last one was that if you multiply the original signal x of t with u of t, then you get the signal only on the right hand side of the time or the y-axis. So the signal exists only for t greater than or equal to 0. Okay. Whenever you multiply any signal with u of t, you get the same signal but only with t greater than or equal to 0. Understand? Is it clear?
Yes, sir.
Yes, sir.
Okay. So this was a quick review of the previous session. Fine. Now today I will ask you to sketch different signals, and you only need to apply some basic operations. Here it is. Fine. Starting with u of minus t plus 2. So how will you find out u of minus t plus 2? First of all, draw u of t. All of you, please do it in parallel. Okay. Sorry. So here we have the u of t first. Okay. Then how do you draw u of minus t? Remember, see, when you are asked to draw the signal, you should always go stepwise. So step 1, if you are asked to draw, let us say u of minus t plus 2, then step 1, this is the step 1, draw unit step function. Why? Because unit step function will be modified to get the u of minus t plus 2. Now second, step 2 will be, first you need to fold the signal. So fold, or you can say time reverse. Perform the time reversal unit step function. Right? So you need to fold the unit step function. So to fold the unit step function, so when you fold it, you are actually performing, you are performing the time reversal. Nothing changes. you get u of minus t. U of minus t is equal to 1 for t less than or equal to 0, and it is 0 for t greater than 0. Earlier we have seen that u of t is equal to 1 for t greater than or equal to 0, and it is 0 for t less than 0. Okay, so now everything changes completely. It is reversed, right? Okay, now the second. Now you add 2 in time here. It means that step 3, perform time shifting of folded signal. That is going to be the third step. Perform time shifting of the folded signal, right? Now look at this. U of minus t plus 2, that means you are adding 2 with every signal. So then you can say that 1 for t greater than or equal to 2, and 0 for t greater than 2. Sorry, t less than or equal to 2. 1 for t less than or equal to 2, and 0 for t greater than 2. Okay? Remember, whenever you add a number to the folded signal, it is actually right shifted. So, for example, here is the signal. So then you start with 2, and then you can go in the same direction. This is u of minus t plus 2. This is 2. This is 0. Here it is t and t. Understand?
Sir, it will not it advance, sir.
No. Who asked that question?
Gaurav, sir.
No. And this thing creates a lot of confusion in many students' mind. Okay. See, whenever you are performing the operation on the folded signal, your concept of delay or advance changes completely. Right? Now try to understand that u of minus t plus 2 is nothing but u of, you can also say that it u of minus of t minus 2. Get it? Understand?
Yes, sir.
Yeah. So here this minus 2, what does it mean? What does it mean?
That is delay.
It should be delayed. So it is delayed. So what you can do, either you can first delay the signal and then you perform the flipping operation. But then you need to keep in mind that you need to flip with respect to that instant only. Understand? So that creates confusion sometimes. So that's why I recommend that you first you first perform the time reversal or folding, and then you do the time shifting. The only thing is that the concept of plus and minus in case of shifted signal will change completely. So whenever you see plus 2 in the folded signal, you should go in the right for plus A. And if you see minus A, then you should go left. Understand? Or in this case, plus 2 and minus 2. Understand?
Yes, sir.
See, it has to do with the original definition. Fine? See, u of t minus 2 is equal to 1 for, tell me, what will happen? Hmm?
Sir, less
Sorry,
than 2.
greater than 2.
Greater than 2.
U of t minus 2 is equal to 1 for t greater than or equal to 2, and it is 0 for t less than 2. Now, if you perform the time shifting operation or the time folding operation of this signal, complete, this is what? Folding, right? So you get u of minus of t minus 2 is equal to, now since you are performing the folding operation right here, so 1 for t, now the only thing is that this sign will change, less than or equal to 2, and here the sign will change, 0 for t greater than 2. So because of this minus, this sign greater than or equal to and less than this sign changes, and this is what u of minus t plus 2. Understand? Understand this?
Yes, sir.
Okay. Yeah. So now if somebody asks you that how will you draw u of minus t minus 2, how will you draw u of minus t minus 2? So then u of minus t minus 2 will start at minus 2. Okay, fine. Now the next one, minus 2 of u of t plus 2. So first of all, draw u of t. I will start from the second. I will start from the second step. You are supposed to draw minus 2 of u of t plus 2. So step 1, draw u of t. And step 2 will be perform time shifting of u of t to get u of t plus 2. Okay. Now you will tell me how will it look like. I will only write u of t plus 2 is equal to 1 and 0 for t for t. Which one?
One when t is greater than or equal to -2.
Yes, very good. So you are supposed to draw u of t plus 2. So 1 when t is greater than or equal to minus 2. And when t is less than minus 2, it will be 0. So it means it will look like this. This is u of t plus 2 because the instant is minus 2. This is 0 and then t greater than 0. So this is t. And no need to draw this. It's fine. What is the amplitude? It is, sorry. What is the amplitude? It is 1. Okay. Now look at this. This is amplitude scaling. Minus 2 means it is amplitude scaling, right? So step 3 will be perform amplitude scaling of u of t plus 2. So x of t, which is equal to minus 2 u of t plus 2 is equal to minus 2. It's very simple. Minus 2 for t greater than or equal to minus 2 and 0 for t less than minus 2. Okay. we are multiplying the original signal with -2. You can call it A, capital A, right? So how will you draw it? How will you draw this? Once again, it starts at -2, but it goes up to -2. Understand? This is -2. This amplitude is -2. This is T. So this will be -2 U of T plus 2. Okay, anybody has any question? See, when it comes to these fundamentals, we can have any type of silly question, right? And it is valid. I understand it. Because relating mathematical function with the graph, doing time shifting, everything simultaneously is a big challenge. Okay, not for you, for all the students. So if you have a question, you can ask me right now. Okay, if you don't have question, you are very good. -4 R of t. Okay, -4 R of t. What will you do? Step 1, draw unit ramp function R of t. How will you draw the unit ramp function? I will write it here. R of t is equal to t for t greater than or equal to 0, and it is 0 for t less than 0. Well defined. So how can you draw R of t?
So through the origin with slope.
So it's very simple. A line which starts at 0 and it has a slope of 45 degree. This is a slope of 45 degree, right? It's a T, right? This is a slope of 45 degree. No need to write this 45 degree, but I'm just trying to explain it. Fine. This is T. Okay. Now you need to perform only one operation, and that is amplitude scaling of the original signal. So that will be step 2. Perform amplitude scaling because there is no shifting operation. Okay, there is no shifting operation, so we can directly go with the amplitude scaling operation. If there is a shifting operation, then first you should do shifting operation and then do the amplitude scaling operation. So perform amplitude scaling. So then x of t is equal to minus 4 r of t is equal to, it's very simple, minus 4t for t greater than or equal to 0, and it is 0 for t less than 0. Now any line x of t is equal to y, let's say, any line with this has a slope of minus 4. Understood? Or what you can say here is that let us say t, right? Now I can put a fictitious 1, 2, 3, 4 like that, and then I put let's say minus 4, minus 8, minus 12, minus 16, and so on. Whereas this is 1, 2, 3, and 4. For t is equal to 1, you will get minus 4. For t is equal to 2, you will get minus 8. For t is equal to 3, you will get minus 12. And for t is equal to 4, you will get minus 16, which will continue up to infinity. So then this should be the intersection points. Understand? So you should draw the final signal which passes through these points, and you call it minus 4 r of t. Understood? It is quite self-explanatory. Okay. I hope. Okay. Is it done?
Yes, sir.
Yes, sir, done.
Okay. Samir, are you noting it down?
Yes, yes, sir.
Okay, fine. Okay, and the last problem is 2r of t minus 2. So I will directly draw this instead of, because I think now you should be able to figure it out, right? So I will directly draw this final answer. It's very simple. X of t is equal to 2 r of t minus 2 is equal to 2 into t minus 2 for t greater than or equal to 2, and it is 0 for t less than 2. Okay, it is time shifted. So let's say it starts here. It is 2 here. Fine. And then its slope is doubled. So earlier, it the original will look like this. This will be the original one. Whereas in this case, it will double. So the revised curve will look like this. Sorry. So this is x of t, which is equal to 2 r of t minus 2. What you can do, you can put the values of 2, 3, 2, 3, 4, 5 like that, right? So if you put t is equal to 2, you will get 0. Okay. If you put t is equal to 3, you will get 2. So here, somewhere you get 2. For t is equal to 4, you get 4 here, and so on. Okay, fine. So this is the direct answer. Okay, the next problem is about,
Sir, please do a previous slide, sir.
sure.
Done, sir.
Okay. Now here, y of n is equal to u of n plus 2 into, look at that, into u of minus n plus 3. So that is the multiplication of two signals, u of n plus 2 and u of minus n plus 3. Fine. So first of all, we need to draw u of n plus 2. Fine. So let's draw u of n plus 2. And then we will also draw u of minus n plus 3, which means we are also going to draw u of minus n plus 3. Okay, u of n plus 2. So u of n plus 2, it's a discrete time step sequence, remember. So it is 1 for n greater than or equal to minus 2. And it is 0 for n less than minus 2. Understand? So I will put 0 here, 1, 2, 3, 4. Similarly, minus 1, minus 2, minus 3, minus 4, and so on. So n plus 2 means it starts at minus 2, minus 1, 0, 1, 2, 3, and so on. So it continues up to infinity. Okay. So there is an advanced okay. There is an advanced of signal. Fine. How do I draw u of minus n plus 3? For that, tell me, how do I draw u of minus n plus 3? For that, I need to first fold the signal or flip the signal, and then I will take the time shifting operation. This is basically a delay. Plus 3 means it's a delay. Fine. So minus n means 0, 1, 2, 3. Minus 1, minus 2, minus 3, minus 4, and so on. So it starts at 0 and goes up to infinity in the negative direction. This is u of minus n. Fine. So then u of minus n plus 3 this is 0, 1, 2, 3, 4, 5, minus 1, minus 2, minus 3, minus 4. So minus n plus 3, that means it starts at 3 and then it goes into the negative direction. Understand? This is u of minus n plus 3. So you can say that mathematically u of minus n plus 3 is equal to is equal to 1 for n less than or equal to 3 and 0 for n greater than 3. Is this clear?
Last one, repeat once again, sir. U of minus n plus 3, sir.
See, u of minus n plus 3 means we are shifting minus n by 3 in the right direction, right hand direction. Okay, so we are shifting it by 3. This is what we did earlier at the beginning of the session. Okay, as I said, when you want to write minus t plus 3 like that, first you fold it and then you shift it. And when you are shifting a folded signal, okay, you should do exactly the opposite of what you would do in the case of positive signal, right? So as I said, u of minus n plus 3 is nothing but u of minus of n minus 3, right? So n minus 3 and you flip it, right? The simplest way is that you perform u minus n and then you add 3 to it. So you will get 1, 2, 3 samples on the right hand side. Understand?
Yes, sir. Yes, sir.
Okay. Now you need to multiply this signal, which is u of n plus 2 and u of minus n plus 3. So multiplication is always done in an instantaneous manner. So tell me, what will you get as a result of multiplication? What will you get as a result of multiplication in this case? Remember, you need to do instantaneous multiplications. That means the value of 0 is multiplied with value of 0 here. The value of 1 is multiplied with value of 1. The value of 2 is multiplied with value of 2 here. So look at the first waveform and third waveform and tell me what will be the resultant one. I will show you. See, from 3 to minus 2, look at the first waveform and the third waveform. From 3 to up to minus 2, both signals are having 1. But at other instances, for example, here, the 4 at 4 and 5 and so on, it is having 0 value, right? Similarly, here at minus 3, minus 4, it is having 0 value. So what will happen if you multiply these two? The 0 here, it is multiplied with 1. What will be the answer?
Zero.
Yes. And 0 at minus 4 here, it is multiplied with 1. So then again answer is 0. Similarly, at 4, here it is 0, here it is 1. So the multiplication will be 0. Here it is 0, here it is 1. So the answer is 0. That means if you multiply the first and third waveform as, or sequence, you can say, then the resultant sequence should look like this. Starting at minus 3. Okay, just a minute. No, not at minus 3, from minus 2, right? Because the first sequence starts from minus 2. So starting from minus 2, one, 2, 3, 4, 5, minus 3, minus 4, minus 5. So at minus 2, it is 1. At minus 1, it is 1. At 0, it is 1. At 1, it is 1. At 2, it is 1. And at 3, it is 1. Everywhere else, it is 0, 0, 0, 0, 0, and so on. Understood? So this is x of n, which is equal to u of n plus 2 into u of minus n plus 3. Always remember, multiplication of two signals is always done in instantaneous manner.
This is the final answer.
Yes, this is the final answer. So we are doing examples which are once in a while asked in the examination. But you must be able to perform any such operation if you are asked to. Faiz, are you there? Yes. Okay. Now the second problem. Okay, I'm giving you 10 minutes to solve these problems. Fine. First, you draw u of n plus 1, n plus 4, sorry. Step 1. I'm telling you the steps. Step 1, draw u of n plus 4. Second, draw u of n minus 2. And third step will be to subtract u of n minus 2 from u of n plus 4. Basically, you are performing n plus 4 minus u of n minus 2. Once again, you will do the addition and subtraction in instantaneous manner. दीपक कुमार, अरबाज, आपको ये सॉल्व करना है, ठीक है। मैं आपको टाइम दे रहा हूं ताकि आप सॉल्व कर सके उसको, और अगर उसमें कोई दिक्कत है तो आप मुझे पूछ सकते हैं एट दी एंड। So there is a difference between a solved examples, noting down a solved example, and doing the unsolved examples on your own. और कोई भी स्टूडेंट रैंडमली कोई भी कॉपी सबमिट नहीं करवाएगा, ठीक है। आई एम चेकिंग ईच एंड एवरी कॉपी। कुछ स्टूडेंट ने सिर्फ नाम का एक पेज रख दिया था लास्ट टाइम, तो उसकी एब्सेंट लगेगी, प्रेजेंट नहीं लगेगी, भले ही आपने 2 घंटे यहाँ पे बर्बाद कर दिए हो। गौरव कुमार,
Yes, sir.
आप कैलकुलेट कर रहे हैं अभी?
Yes, sir. Done, sir.
ओके, गुड। If you finish early, let me know. Okay. I will simply calculate the final answer. U of n plus 4 is equal to 1 for n greater than or equal to minus 4, and it is 0 for n less than minus 4, and u of n minus 2 is equal to 1 for n greater than or equal to 2 and 0 for n less than 2. Okay, so then u of n plus 4 minus u of n minus 2 is equal to 1 for minus 4 less than or equal to n less than or equal to 2, and it is 0 elsewhere. Okay, now how do you draw this? Fine, it starts at 0, so it's 0 here, 1, 2, minus 1, minus 2, minus 3, and minus 4, minus 5, minus 6. Now let me share an interesting fact with you. This is not 2, it is 1. So here we are going to erase this, and here I will put 0, 0, 0, and so on. Why is it so? Can anybody explain?
Because both are 1 at that instant.
Yes, very good. Because at n is equal to 2, both are 1. So it will start at minus 4, it will go up to 1, and the amplitude is 1. So you should do some practice related to this also. Fine. You can find the solve examples as well as unsolved examples in the book Anand Kumar. As well as there are few other books which you can refer. Fine. But now we have a very, very important last 10 number. Problem number 10. Okay. If you recall, this was problem number 9. This was problem number 8. Right. Okay. So last one in this tutorial is problem number 10. The problem number 10 looks like this. Okay, what is the statement of this problem? It says express the following signals as sum of singular functions. Okay, sum means it can be addition, it can be subtraction, but express the following signals as sum of singular functions. Fine. So let us begin with this 0, 1, 2, 3, 4, -1, -2, -3, -4, -5, and so on. And then it is defined from -2 to 1. So -2, before that it is 0. At -1 it is 1. At 0 it is 1. At 1 it is 1. At 2 is 0. 3 is 0. 4 is 0. This is x of n. So question is, express the following signals as sum of singular functions. Okay, what you are supposed to do here is, the result is given, you need to go back to the equation. So far we had a particular equation, and then we draw individual signals and then find out the resultant signal. Here the resultant signal is given, and then you are supposed to find out the original functions, mathematical function I mean. Okay, how will you do that? Okay, now there are two ways to express this. One, you can consider a signal at -2 individually as delta of n plus 2. Okay, delta of n plus 2 is given by 1 for n is equal to 2, and it is 0 when n is not equal to 2. So then you get this. Then you say that delta of n plus 1 is equal to 1 for n is equal to 1, and it is 0 if n is not equal to 1. So you take this one. Similarly, delta of n is equal to 1 for n is equal to 0, and 0 if n is not equal to 0. So you are done with this. And then you say delta of n minus 1, sorry, it's -2. Minus n minus 1. Here it is 1 for n is equal to 1, and 0 if n is not equal to 1. So we have taken individual functions, delta of n plus 2, n plus 1, n, n minus 1. So then I can write that x of n is equal to delta of n plus 2 plus delta of n plus 1 plus delta of n plus delta of n minus 1. or I can write this as an appropriate mathematical function, which is n is equal to -2 to 1 delta of n minus k. So if you put k is equal to -2, you will get n plus 2. Now this is coming out of experience, so don't try this at present, but you can certainly write like this. Or in other words, what you can do, for example, you already have this function, sorry, so I'm not going to redraw it. I have an amazing facility called copy paste. Fine. Okay, now if you look at this, then I can say that the original function could be a unit step function from here, because ultimately it's a rectangular function, and rectangular function, as we know, we can obtain, we have already seen here, we can obtain this kind of rectangular function from the subtraction of unit step sequence or unit step function, right? So then let us begin with, because ultimately this is what? A unit step function. So let us begin with a unit step function. So here we have n. Of course, we have 0, 1, 2, 3, 4, and -1, -2, -3, -4. Okay, now it starts at -2. So let us say that the signal starts at -2, -1, 0, and 1. And I can continue this up to infinity. What do I call this? The function has 1 for n greater than or equal to -2, and it has 0 for n less than -2. How do I define this function? Samir, you answer me. Wait a minute, Gaurav. Samir, you answer me.
Yes,
How
sir.
do I define this function?
It's u of t is equals to uh, one minute, huh, sir?
Hmm.
Okay. It's u of t plus 2.
It's not t, dear. First of all, it is n,
Sorry, n, yeah,
right?
n
So it should be n plus 2.
plus 2.
Okay, it's a discrete time, and in
Yes,
discrete
yes.
time always keep in mind that you should write independent variable as n. So it is n plus 2. Very good. Now you need to define another function here, which will give you, ultimately it will give you the original function. So basically I can say that my revised function or desired function, okay, that is x1 of n is equal to the original, the u of n plus 2 minus x of n. I can write it like this. Or you simply look at the values, instantaneous values. Here it is 1, 1, 1, 1. Here it is 0, 0, 0. Here also it is 0 and 0. Fine. Now you will construct the next function here. Sorry. Right? And once again you will get 0, 1, row 0, 1, 2, 3, 4, minus 1, minus 2, minus 3, minus 4. Okay. And now look at the original result or original signal and look at the revised result. Now we need to perform what we need to perform. We need to perform some kind of subtraction here, right? So that I can also write here as x of n is equal to u of n plus 2 minus x1 of n. And I call this x1 of n. Okay. So I'm going to subtract this 2 so that I get the original one. Or you can, what you can do, you can subtract x of n from u of n plus 2 so that you can get final result. Okay. Now I think this one is better. This one is better. U of n plus 2 minus x1 x of n. Okay. So that you can get x of n is equal to u of n plus 2 minus x1 of n. Now x1 of n is unknown. Now subtract u of n plus 2 and x of n. What will you get? At minus 4, 0 minus 0. What is it? At minus 4, 0 minus 0. And it is 0. At minus 3, 0 minus 0. So you get 0. At minus 2, 1 minus 1. Look at that. At minus 2, 1 minus 1. So what will you get? Say something.
0.
It's 0. At minus 1, 1 minus 1. So you get 0. At 0, 1 minus 1. So you get 0. At 1, 1 minus 1. So you get 0. At 2, here it is 1. Here it is 0. So 1 minus 0.
1.
1. Similarly, at 3, 1 minus 0. So you get 1. At 4, 1 minus 0. So you get 1. And this continues. Now, what will you call this function? What will you call this function? Remember, it is 1 here, 1 here, 1 here, and everywhere 1.
It's a step, sir.
Yes, it's a step function. Very good. Okay. And what is the precise mathematical formula for it? Okay. If you don't know, it's very simple. You are getting 1 for n greater than or equal to 2 and 0 for n less than 2. How should I define this? It's a unit step function, so fine. How should I define this?
Sir, argument will be n minus 2.
It's going to
u of
be
n
n
minus 2.
minus 2. Perfectly fine. That means your unknown x1 of n is u of n minus 2. So I can write the answer as x of n is equal to u of n plus 2 minus u of n minus 2. And that is my answer. Understand? So instead of writing x1 of n here, you can put simply u of n minus 2. Is it clear?
Yes.
Okay. Now, I'm giving you another example just like this, and you do it on your own. Let me tell you the method. The method is very simple, right? You want to decompose x of n into two functions. You want to decompose x of n into two functions, x1 of n and x2 of n. If you know that, you can subtract it, no problem. Okay, but you want to find these two functions, x1 of n and x2 of n, or you can say minus, whatever way you want to write it. Fine. And you want to find out x1 of n and x2 of n individually. Now the next problem is, okay, it's like this. Here we have n. This is problem number 2. In sub problem number 2 actually, in problem number 10. And here we have 0, 1. From 2 you get 1, 3, 4, 5. From 6 onwards, you once again you get 0 and 0. Minus 1, minus 2. This is x of n. Okay. You can take 5 to 7 minutes to solve this problem. Look at the starting instant. Where does it start? It starts at n is equal to 2, right? And it is going to take a form of step function. The key for solution of such problems is to choose the first function x1 of n. Arbaz? Arbaz,
Yes, sir. Yes, sir.
are you done with this problem solution?
I'm doing, sir.
Okay. Okay, Gaurav Kumar got the correct answer. Very good, Gaurav. Amit Kumar, what about you?
Doing, sir.
Mm-hmm.
Hello, sir.
Yes.
Sir, can you repeat the previous example after the first step?
Okay. After the first step, see, first step is to determine the function u x1 of n, the first function. Now, how can you get the idea of first function? By looking at the original function. Now, the original function it looks like a step function, but interrupted in between. So it is basically a rectangular function. Okay, it is basically a rectangular function, and the rectangular function is obtained by the step function only. Remember, right? Now you look at the instant at which your signal is starting. In our case, it is starting at -2. So then you can choose a unit step function which starts at -2 and it goes up to infinity. That means it is 1 for all values of n greater than or equal to -2. And it is 0 for n less than -2. Right? This function is called u of n plus 2. Okay. Now, after you have got first function, your job is to find out the second function. Normally, we do the subtraction, right? So you can say that x1 of n is obtained by u of n plus 2 minus x of n. X of n is the original function, right? So you can always obtain the next function from the function that you have assumed minus the original function. So original function is x of n. So now you have x1 of n is equal to u of n plus 2 minus x of n. Okay. Now you will perform the subtraction of u of n plus 2 and x of n. So it is 0 minus 0, 0 minus 0, 1 minus 1, which is 0 here, 1 minus 1, so it is 0 here, 1 minus 1 at 0, so you get 0 here. At instant 1, it is 1 minus 1 again, So you get 0. But instant 2, here it is 1, here it is 0. So you get 1 here. At instant 3, u of n plus 2 is 1, but original function is 0. So 1 minus 0 is 1. And that will continue. Now, which function is this? So the function starts at 2, goes up to infinity, and it is 1 for all these values. So for n greater than or equal to 2, it is 1. Mathematically, that function is u of n minus 2. So that means it is u of n minus 2. Understand?
Yes, sir.
That is the methodology to solve such problems. So you need to apply the same methodology in this example. Remember, in examination, you may not be fortunate enough. So it can be any signal. Faiz, you are supposed to solve this problem, right?
Yes, sir, I'm doing.
Are you done it? Have you done it?
No, sir.
Okay. So please try to finish it.
Okay.
See, if you respond quickly, if you do it quickly, of course, with understanding, but if you do it quickly, then we will be able to move to the next problem, right? Otherwise, this is the third week. So I may have to give you the rest of the problems as a homework. Deepak Kumar, what have you written here? Okay, let me draw the first signal and see if you can get. So here it is 0, 1, 2, 3, 4, 5, 6, 7, -1 and -2. It's 0 here, 0 here, 0 here, 0 up to 1, and then from 2 onwards, I draw 1. Okay, the function is defined like this. It is 1 for n greater than or equal to 2, and it is 0 for n less than 2. How do you define this mathematically? How do you define this mathematically? Arbaz?
Yes, sir.
How do you define this function mathematically? 1 for n greater than or equal to 2 and 0 for n less than 2.
Sir, n less than 2, sir.
क्या बोला?
Sir, n less than 2, sir.
Now that's where you are going wrong. Dear, it is u of n minus 2. Look at the instant. It starts at 2, right? So it is n minus 2, not n plus 2, remember. If it is u of n plus 2, then it will start at minus 2. Understand? Now you subtract the the second function and the first function. And tell me what will you get? Okay. Now, at 0, it is 0 minus 0. So you get 0. At 1, it is 0 minus 0. So you get 0. At 2, 1 minus 1. So it is 0. At 3, 1 minus 1. So it is 0. At 4, 1 minus 1. So it is 0. At 5, 1 minus 1. So it is 0. At 6, this is 1. This is 0. So you get 1 here. At 7, 1 here, 0 here. So you get 1 here. Similarly, at 8 also, the same will happen. And this will continue. Now you tell me what should be the function when it is 1 for n greater than or equal to 6 and 0 for n less than 6. Faiz, tell me what will be the mathematical function if it is 1 for n greater than or equal to 6 and 0 for n less than 6.
So,
Yes?
sir, u f of n minus
U of n minus 6.
6, right? It is u of
Yes, sir.
n minus 6. So that means you can obtain x of n as u of n minus 2 minus u of n minus 6, which means if you subtract this first function and the second function, you will get the original function. So this is your answer. In examination, if you draw this properly and explain, then certainly you will get 3 marks in 5 minutes.
सर 5 मिनट से भी कम ही लग रहा है.
For that, you need to have a practice. In signals and systems, time is not going to be an issue, but you must know the answer. Okay. So probably we can only discuss up to this point, right? We will talk about rest of the problems in the next tutorial.